Ladies and gentlemen, in this tutorial we are going to learn about complex numbers. What should we know when it comes to complex numbers? We have what we call purely imaginary numbers. So these numbers are numbers, for example, we have 5 negative. This we can call it as a purely imaginable number, or we have this or this. We can call this as a purely imaginable number. This 5 can also be written as it is just one and the same, as well as this one can be written as this, just one and the same. So we dive deeper into complex numbers. What other things should we know when it comes to complex numbers? A complex number is a number that is in form of x plus I y, where x is equal to a real part, and y is equal to an imaginary part. So this x can also represent, these are the terms that you should master, know them by heart, raise, and as well as imz can also go to 1. So in this case we are saying that x is a real part and y is an imaginary part. Let us now look at the algebraic operations of complex numbers. What should we know? For example, we have been given addition of complex numbers. We have been given 3 plus 4i, we add by 7 plus 2i. They tell us to add this complex number. What should we know? We should add the real part with the real part, as well as the imaginary part with the imaginary part. So in this case we're adding 3 plus 7, close brackets. These are the rules that you should master, which is I plus 2i is equal to 10 plus 6i. So this is what you should know when it comes to addition. When they tell us to subtract the complex numbers, we have example. In this case we have this one, they tell us to subtract this complex number. What do we have? We have 3 minus 7 plus 3 plus minus 2i, which is equal to negative 4 plus 2i. So this is what you should know when it comes to addition and subtraction of complex numbers. So we go to power, the theory in which we say power of I. We call it power of I, which is this I that we are writing to a complex number. What are its powers? For example, we all know that I is equal to this. This is one thing that we should know. I is always equal to the square root of negative 1. This is what you should know. So if you are given this I squared, it is meaning to say we have here, this is negative 1 multiplied by negative 1, and when you follow the rules of surd, you find that it is equal to negative 1. So I squared is equal to negative 1. So this is one thing that you should know. What if you are given this? I power 3. We know at first to say I, we know to say I plus 2 is one and the same as I this. It's just one and the same. Let me have this. We know to say it's one and the same as I. My board is not writing. That's the same as I plus I, which is equal to negative 1 multiplied by I. So we know to say I power 3 is equal to I negative. So this is something that you should know where it is coming from. So we have I to the power 4 is equal to I 3 times I. Just one and the same. We have I. We know that I power 3 is equal to I, and I is equal to I equals to negative I squared, which is just equal to negative 1 multiplied by negative 1, which is equal to 1. So we need to master especially this one, which is equal to I4 is equal to 1. So that's what we should know when it comes to 6I power 6 is equal to negative I4 I2, which is equal to 1 multiplied by negative 1, then it is equal to 1. So these are the things that we should master by heart. What if we've been given an example to say I negative 36? We have been given to work out this one, to simplify it into simpler terms. First thing that we should take note of, we should multiply this 86 by 4. So when we multiply it by 4, we find that it is 9. So that's 9. Is there a remainder in this 86? We find that the remainder is 0. So write in form of this, where we multiply by that number that it gave us, then we add plus the remainder. We find that I4 is 1. Is 1 equal to 1 9, which is just the same as I to the power 0. These are rules of algebra. In simple terms, we can write like this. So if we have A1 plus 2, it is just the same as A. Sorry, my pen is not writing properly. Just the same as A. Sorry, just the same as A plus 3. This is just one and the same. So here we write anything to the power 0, we know it's 1. So then answer here is equal to 1. So we have another one which we have been given I is equal to I power 47. What is 4 divided by 49? We have I. We find that 4 divided by 49 divided by 4, we have 12. So we get the 4, we multiply it by 12, and what's the remainder? We find that the remainder is 1. So when we multiply 12 multiplied by 4 and plus 1, the answer is given as 49. Which in simpler terms, we can write like this. are we following? Which is this. So we find that I4 I4 I to the power 4, it's just the same as 1. So we get 1 to the power 12 multiplied by I. So we find that we are getting the answer, which is 12, 1 to the power 12 multiplied by I, which is just the same as I. So if you have observed the answers that we are getting, if we are not getting I, then we are getting 1. If we are not getting 1, then it's -1. If you are not getting -1, then it's -I. So this, if you have observed the pattern, this is what you should be getting whenever you have a bigger figure. So we move to multiplication. We move to multiplication of complex numbers. So we have to master the theorem where when we have z equal to x plus the imaginary part, and we have w equal to u plus the imaginary part, we need to master this formula, and they tell us to multiply it. X here, it will multiply everything in the w, then you add, then the imaginary part of z will also multiply everything in w. So this is one thing that you should know. For example, you have been given 3I, you multiply by, you have been given, for example, 3z equals 3 plus 4I, and we are also been given w is equal to 7 plus 2I. We have been given to multiply these two complex numbers. What's one thing that you should know? You need to multiply everything. Multiply this 4I and 7 plus 2I. Multiply here. We will multiply 3 multiplied by everything inside the second one. We multiply it, then we add here plus also multiply what is inside here. So we find that, allow me to erase this part. Find that when we multiply everything here, we have 2I, 21, we have 21, then 3 plus 3 multiplied by 7 is 21, then we have 6I, then for the second one we have 28I, then we have plus 8I squared. Mind you, we are multiplying 4I multiplied by 2I. We have this. So after we have this, we observe to say, after we simplify it, we find that we have, let me copy it separately. I said we add this, add this plus 8I squared. Find that we have 21 plus 6I plus 28 is equal to 34I. But for this one, I squared, we learned to say I squared is just the same as -1. So this is where it applies. So when we add here, we find that we have 13 plus 34I, and therefore we have our 13 as our real part and 34 as our imaginary part. So this is what we should know when it comes to multiplication of complex. So we also have what we call conjugate of the complex number, where now everyone is familiar with when we say conjugate. So when they give you this one and they tell you, they give you this one plus I1, they tell you to find the conjugate of this number, you write this. So these are the symbols that you should observe here where it's when it's positive, we change it to negative. When it's negative, change it to positive, as this stands for conjugate. So this symbol here, whenever you see it in an exam, you use it, you know, and differentiate to say this symbol means conjugate. So when they tell us to divide complex numbers where we have been given z over w, which is equal to x plus I is equal to u plus I v. Sorry for my handwriting. U plus IV. What should come into your mind whenever you are dividing complex numbers? You should multiply the conjugate of the denominator twice. Where, for example, this one, in this case, we get the conjugate of the denominator. This is IV. So we multiply it with the numerator. This is I, and we multiply it with the denominator. So this is what we'll be doing when it comes to dividing of complex numbers. Multiply the conjugate by the numerator and the denominator. So for example, we have been given 3, 6i, we must divide by 2i. What should come into your mind? You analyze it like this. We have 3y divided by I. So what we do is to get why we are multiplying here is because we want to get rid of this I here. So in this case, we will just multiply by I. You multiply here. You find that you get 3i minus 6i. Sorry, you get this 2i squared, which is in simpler terms 3i minus 6 minus 1 is equal to negative this, which is when simplified further to equal to 3i plus 6 over negative 2, and which is just the same as negative, which is just the same as negative 3 minus 3 over 2i. Here we have 2 and here we have I. So we have negative 3 as our real part and negative 3 over 2 as our imaginary part. What if you have been given 1 plus I? What can you do? You have been given 1 plus I. You divide it by 3. You have been given this. They want you to divide it using that method. What should you do? So in this case, you will write the numerator. We have an I here. We have 3 plus 4i. Find that you multiply it. We said you multiply it by the conjugate of the denominator, and here we also have the conjugate of the denominator. So you find out that this one, when we multiply 1 multiplied by 3, we have this one multiplied by 4i, which is this. Then when you multiply I multiplied by 3, we get 3i. Then we will multiply I multiplied by negative 4i, we will get negative 4i squared. So, and here on the denominator we have 3 multiplied by 9, we have 3 multiplied by 3, we have 9. Then we have 3 multiplied by negative 4i, we have negative 12i. Then when we multiply negative 4i multiplied by 3 will have plus 12i. Then when we multiply positive 4i multiplied by negative 4i will have negative 16i squared. So what should you know when it comes to this? You know that this here it's equal to negative 1, and this here is also as well equal to negative 1. So when you simplify further this top part, you find that you have 7 over 25 minus 1 over 25i. So this is what you should know when it comes to division of complex numbers. The only thing that you should master is multiplying the conjugate of the denominator by the numerator and the denominator. So thank you for watching. You can text me on WhatsApp if you have any concern. Ladies and gentlemen, in this tutorial we are going to learn about the complex plane. What do we mean when we say the complex plane? Mind you, it comes from the word Cartesian plane, now in form of a complex plane. So what we mean when we say a complex plane, we mean we have this line here and we have this line here. Short, the x-axis is called the ray z and the y-axis is called the mz. So this is what we mean when we talk of the complex plane. Now we have an angle here and we have the y and the x coordinate as well as the resultant r. But all these things that we are talking of, they have their names. For example, r can be called modulus. We can call r as modulus and or absolute or absolute. So r can be called modulus or absolute. We also have the angle which is theta. Theta can be called as an argument or it can be called amplitude. So r can be called modulus or absolute, and the theta can be called an argument or amplitude. So these are the terms that you and I should master when it comes to the complex plane. So for example, we have been given 2 plus 2i the square root of 3. This is I, mind you. Then we are asked in this question to find the modulus and the argument, which is when finding the modulus, we all know that modulus is r and the amplitude or the argument is the theta. So for us to find these two, what first should we do? We need to identify what is x and what is y. In this case, x is equal to 2 and y is equal to 2, 3. So this is the first thing that we should deal with. So what should we do when we are finding r? So when we are finding r, which is the modulus, we find it by using the Cartesian, the Pythagoras theorem. But the first thing that you should understand before writing anything, you should first understand the graph. How is this graph coming out? For example, when you draw the x and y coordinates, for example, we know that x is equal to 2, which means it is somewhere here, and the y component is equal to 2 pi over square root of 3. It means it is as well somewhere here. So what should we do? This indicates and shows to say the angle is in the first quadrant because the x and the y coordinates, they are all in the positive side, means it is in this quadrant A. So in this case we can write we can write it in this form just to simplify things. We said it is somewhere here, so it means that this is how our graph is coming out. This should be in our minds. This should be in our mind, and we have an angle somewhere there. So in this case, when we are finding the modulus or the absolute value, which is r, we do this, where we find using the Pythagoras theorem. We find to say we have here 4 and we have 12, which is 16 over 4. So when this what we have found here, it's a modulus or the absolute. So this is how we find the modulus or the absolute. We've also been taught to find the argument in this case, which is an angle. So when finding an angle of the Pythagoras theorem, mind you, it is that we drew a sample which is coming out like this. We have x and we have y. Finding the angle, we can use tan theta is equal to y over x. In this case, we have tan equals y, which is 2 this over 2. We have, in this case, we'll get a 3a, which is theta is equal to tan inverse of the square root of 3, which is equal to 60. Now when we convert it to radian, let me do this. When we convert it to radian, we can also have pi over 3. You can write whatsoever answer you are comfortable with. So we have also been given another example, which is z equals I, which is equals to 1, -1 minus I. Now in this example, we have been taught to find the modulus or the absolute value and the argument. Well, what should we do when we are asked in the first place? First of all, we need to come up with a rough sketch of what they are talking about. In this case, we know that x is equal to -1 and y is equal to -1. This is what you should keep in mind. So in this case, we have something like this. So we have the angle in this quadrant, in the third quadrant. This thing should be in our mind. So once we have found this, we can now start working out. We have the r, which is equal to this plus -1 this. So when we simplify, we are having a 2 here. So r is equal to the square root of 2. So we have the modulus or the absolute value to be 2, the square root of 2. What is now the argument or the amplitude in this case? So we have tan theta is equal to 1 over 2 over 1. So we will have this equal to -1, which is equal to 40, which is equal to 45 in this case. So Once we have found this, we know to say the angle is 45. But remember what I told you in the first place. In the first place, we said the angle is in the third quadrant. So the 45 that we have found, it's this one. But when finding the O angle, we don't consider this angle. Instead, we consider the angle from moving from the x-axis to the same R, that is touching R. So since we have found 45A, we add plus 180, which will equal 220, which will equal 225. When we add 225 degrees, this you should never forget. It should be in your minds. We'll now look at the polar or trigonometric form. So we'll look at the polar or trigonometric form of complex numbers. What should you know when it comes to the polar or the trigonometric form of complex numbers? Here we knew that x is equal to this and y here, so we just need to add this or r sine this theta. So this is what we add the polar or the trigonometric form. So when we have this one, in this case z equals to x plus I y, it is just one and the same as where there is x, we replace with r cos theta, plus where there is I y, we replace I r sine theta. In simpler terms, when we factor out r, we have r cos theta plus I sine theta. So these are the formulas that you should know. These you should know how things are working out. So this should come into your mind when you are asked to say write z equals x plus iy in polar form. You should write it as r open bracket cos theta plus I sine theta. This you should know into your minds. For example, in this case, we have been asked to express the complex number z equals 1 minus 3 in polar form. What should be the first step that you should consider when working out? The first step should be on the angle. What I told you, it should be on the graph. You picture it first on a rough sketch. In this case, we have x here, so we know that we have the x which is equal to 1 and the y which is equal to negative this in simpler terms. So we know that x is in the positive axis while y is in the negative axis. So it means this angle will be in the fourth quadrant, isn't it? Yeah, that's it. So this angle will move from the x coordinate. We consider everywhere, we consider this angle A. So that should be the picture first of all. So we will now look for r in this case, which is 1 this plus this, we get we get a 4, which is equal to a 2. The angle in this case will get y over x, and we'll have here as this. So in this case we'll have the tan theta, which is tan theta, the negative of this follows, which is 300 degrees. So we even now confirm to say 300 degrees is in the third quadrant, isn't it? Yeah, it is. So once we have found the angle and r, now it is possible for us to convert z into polar form. So the z, which was initially 1 minus I, this is now equal to 2 open bracket cos 300, now the angle, plus I sine, sorry, let me write properly so that you see, we have sine 300. So this is the conversion into the polar form. So where we were writing to say x, z is equal to x plus iy, we write r cos theta plus sine theta. So the r here is representing 2 in this case, and the theta is representing 300 in this case. So when we are asked to convert from we are asked to convert into the polar form, we do as wise. So what if they ask you to convert from polar to rectangular? What is rectangular, by the way? Rectangular is this form. This form, it is called rectangular. So should not be confused when you hear such terminologies. So we have 8 cos 210 plus I sine 210. What's the first thing that should come into mind when you start working out? I told you you should first imagine it on a plane. You see the angle. What's the angle that you are having? You are having 210, which means this is in the third quadrant. When you picture this into this form, now you can work out. You can work out the requirements that are needed. So in this case, what should we start with? Since we know to say it is in the third quadrant, this is now where those trigonometric this is now where those special angles we are talking about starts now applying. So in this case we have cos 210. If you have not watched the special angle video on the special angle video, I recorded a video on special angles on the trigonometries. Go back and watch it. So we have here, which is 210. We analyze it here. If you have 210 here in the third quadrant, this 210 now represents the whole thing now up to here. What is this angle here? So we'll do this whole thing is 180. We'll do 210 minus 180. It will equal a 30. So when it equals now a 30, this is the angle A that they are talking about. Angles here, this angle 30, it's one of the special angles. So since we have come up with the special angle, which is 30, we know it is in the x. We know to say cos 210 is in the third quadrant. We can write the negative sign in advance, which is cos 30, which will now equal those special angles, go back and write it. We also know sine 210 is in the third quadrant, and we know to say in the third quadrant y is negative, so we write sine 30, which is equal to 1 over 2. So sine 30 is equal to half. So this is due to this thing that I told you. We know it is moving in this direction, so the x has to be negative and the y as well has to be negative. So once we have found this, we are comfortable to say x is equal to negative this and y is equal to this. But that's not the case here. Let us record this. Let us not rub this. So in this case now, since we know from the question to say 8 is equal to cos 210 plus I sine 210, and we have found to say 8 the cos 210, we found to say it's equal to this. That's what we found, and we found that sine 210 it is equal to 1 over 2 is. So we can conclude now by multiplying 8 multiplied by the square root of 3 over 2 negative, which will give us this negative 4 the square root of 3 minus 4 1 I. So this thing now we have converted from polar form to rectangular form. As simple as this, guys. Just need to go through. So now we move to the multiplication of polar complex numbers. For example, we have been given z here. These are the theorem z multiplied by z1 multiplied by z2. In this case, we'll write it as r1. This is the angle here is angle 1 plus I sine angle 1, close bracket, closed brackets here. So when you close the brackets, we multiply it, which is dot sign, multiply by the r2 in the z2, multiply it by this, the angle, these two stands for angle 2. Okay, it means the two angles must be different. So how do we multiply now? How do we multiply them? So these are very simple. The r will multiply with the r. So in this case, it is equal to r1 multiplied by r2. r1 multiplied by r2 will equal to cos. We start with cos. Then the angles that are, which is angle 1 and angle 2, will add. We'll add angle 1 plus angle 2 plus the I now, which is sine theta, angle 1 plus angle 2. So this is how you go about it when you are multiplying polar complex numbers. So when you are dividing, take note, this multiplication here, it will be r divided by r1 divided by r2. So instead of multiplying here, we have a negative, and here when we are dividing, instead of the positive here, a addition sign, we have a negative sign. So this should be in your mind. You have to apply those rules. Let me just write it so that you get what I'm saying. We have this, which is r1 cos angle 1 plus sine this, which will equal to cos angle 2 plus sine angle 2. Here we have an I, and here we have an I. So the resulting thing here, we have me write it this side, we have R1 this cos plus sine this theta over R2 cos theta 2 plus 1 sine this 2 here. Now we learned to say when you are dividing complex numbers, you multiply by the conjugate of the denominator. Go back. So here we multiply by the conjugate of the denominator. Here we have a sine minus this and over this minus sine theta 2. So you multiply by the denominator. So we have been given this example where we are asked as z1 is equal to 1 plus I this, z2 is equal to this negative the square root of 3 plus I. So this, when you the first thing that you should do is to express it into polar form. So when you express into polar form, you can show your works on your own. When you express that into polar form, you have z1 to be equal to 2 cos 2 phi. Mind you, the angle has been converted into radian, so you can work out in whatsoever formula that you find fit. So here we have 2 cos 5 sine 5 over 6. So this is what we are getting when we convert it into polar form. So once we have converted, now it's possible for us now to solve it. We have z1, we have z, sorry, handwriting is bad, it's terrible. We have z1 dot z2, which will equal to 2 of open bracket cos 2 pi over 3 plus 1 sine 2 pi over 3. Close brackets, you multiply it by 2 over cos 5x over 8 plus 5 pi over 6 plus I sine 5 pi over 6. So you multiply this. When you multiply this, you will get a 4 here. Remember the rules that I told you previously: 2 multiplied by 2, which is 4, and the cos here, the angles inside, the angles will add. Remember what I told you: since you are multiplying, the angles add, but when you are dividing, they subtract. This is what I taught you previously. So the sign here will open the brackets here, which is the angles will add also this side, which is plus. Remember, I told you the angles are converted into radians. You can also do it or work out in degrees. So once you have found this, you get a 4 here, which is cos 3 pi plus sine 3 this. So we have found out to say 3 pi is 90. So in simpler terms, you can have a cos 90 which is a 0, and we know that a sine 90 it's a negative 1. So it is in order for us to just write negative 4i as our final answer. So this is what you and I should understand in as much as this thing is concerned. You can also try it for division and see how things will work out. We can try it together. We have z1 here and z2, then we'll have a 2 here, which is cos, open brackets here, we have 2 over 3 plus sine 2 pi over 3, this is ia over 3. So we have this one is equal to 2 open brackets cos 5 over 6 plus I sine 5 over 6. So you do what should come into your mind when you see the division, when you see the division symbol? What should you do? You divide the r. You remember what I told you, right? Instead of multiplying, now you divide. Then the angles inside, they divide each other. So in this case, you have the I sine 2 pi over 3 minus 5 pi over 6, which is just in simpler terms as cos negative of this plus minus we have the angle. In this case it's negative. So when you reach this stage, when you observe that the angles inside here they are negative, what should come into your mind? You should just remove the negative, and when you remove the negative, automatically this sign here becomes a negative. So you remove the negative, automatically becomes this over 2 minus 1 over 2i. So this is what should be in your mind when you see problems like this. The square root of 3 over 2, it means cause we need to change it. We need to change it into degrees for us to come up with simpler terms, just one and the same.